Welcome back, everyone. Okay, let's dive right into this explainer. Today, we're getting into a real masterclass on job site quality control. We're zeroing in on the absolutely critical role of the Shotcre inspector when it comes to evaluating materials and mixed properties. If you're heading out to the field or will be gearing up for your ACI Shotcrete inspector exam, this is that foundational knowledge you absolutely need to lock down. Let's take a quick look at our roadmap for today. We're going to cover core role and materials, wet mix versus dry mix differences, mix components, delivery factors, some real-world field scenarios, and wrap it all up with our key takeaways. All right, starting off with Section 1, core role and materials.
So the crucial point we really need to hammer home here is this. Shotcrete is not simply concrete placed through a hose, right? It is a highly engineered system. The mixture literally has to be completely compatible with the delivery process, the pumping equipment, the required structural performance, and all those unpredictable, ever-changing field conditions. I mean, think about it. A mix that works perfectly fine in a normal, conventional concrete pour, that same mix could be an absolute disaster if you try to force it through a small diameter shotcrete line.
And that brings us to a massive exam alert, and honestly, just a stark field reality regarding your role as the inspector. Your job is to observe, verify, document, and report. You are not normally responsible for actually designing the mixture. Now, that being said, you absolutely must understand what the engineer has approved. Why? Well, because you're the eyes on the ground. You need to be able to spot significant field changes instantly and know exactly when the material showing up on site suddenly doesn't match the approved, qualified system. Moving on to Section 2, wet mix versus dry mix differences. When we break it down, the fundamental difference between these two really comes down to one thing: water. In wet mix shotcrete, the water is already part of the mixture long before the material ever reaches the nozzle. So it relies heavily on having just the right amount of paste, a solid water-cementitious materials ratio, and proper aggregate grading. Honestly, just to physically move through the pump and the hose. Pumpability is the name of the game here. But in contrast with dry mix shotcrete, the water is added right at the nozzle. This means the whole operation is highly dependent on the nozzle man's visual control. And this brilliantly illustrates what we mean. In practice, good visual control for dry mix gives you a surface with a nice, moist appearance, but without any excessive wetness. But look at the bad practice. If the nozzle man uses too little water, the mix is going to look super dry, dark, kind of sandy, and that leads to massive amounts of rebound, terrible encapsulation behind the rebar, and really weak laminations. On the flip side, if they crank up the water too much, you're going to see the material sagging, sloughing off, or just completely losing adhesion on vertical and overhead surfaces. It's a delicate balance. Next up, Section 3, mix components, specifically aggregates, admixtures, and fibers. Let's walk through these. Starting with aggregates, their size and grading completely change pumpability, rebound, finishability, and encapsulation. Now keep in mind, larger particles actually tend to rebound way more easily than smaller ones. So the material that actually stays on the wall, it can have a totally different composition than what was originally dumped into the hopper. Oh, and remember, rebound should never, ever be intentionally reincorporated into the work. Just don't do it. Next, we have admixtures. Things like water reducers, retarders, hydration control systems, and accelerators. These can radically change how shotcrete behaves. But they absolutely need compatibility, which is exactly why pre-construction testing is so vital. Finally, fibers. They're great for improving post-cracking behavior and toughness, but they will definitely impact mixing, pumping, and finishing. So from your viewpoint as the inspector, your core job here is to verify that the production mixture corresponds exactly to the approved or qualified system, period. Don't ever just assume that all fiber-reinforced shotcrete is exactly the same. It's not. You have to check the specific fiber type and the exact required dosage against the delivery tickets. Plus, you need to train your eye to recognize sudden changes in consistency. If a mix comes out looking way wetter, drier, stickier, or just less stable than before, well, that's a huge red flag that there's been a change in water, admixture dosage, or maybe even how the equipment is being run.
Okay, Section 4, delivery and environmental factors.
Now, temperature is a massive factor here. You've got to remember this. The material temperature is actually part of the mixture condition itself. It is not just a weather measurement. Hot material can stiffen up incredibly fast, while cold material might develop its strength painfully slowly. But beyond just checking the thermometer, you've got to be on the lookout for prolonged delivery delays. You should constantly be asking yourself the critical inspection questions. When was this batch made? Has it been sitting in the truck too long? Has anyone added water or any other materials at the site without authorization? Did the admixture dosage magically change? You really have to stay on top of these things. Let's move to Section 5 and see how this builds. Field scenarios applying the framework. All right, here is our first real-world field problem. Picture this. You're on a wet mix job. Things have been pumping perfectly consistently all morning. But right after lunch, a new truck rolls up, and the material is visibly, obviously, much wetter. The pump operator just kind of shrugs and tells you, hey, it's going to pump easier. Take a second and think about this. What should you, as the inspector, actually do in this very common scenario, where the crew is clearly prioritizing an easy placement over actual material quality?
Let's run this straight through our 4-step inspection framework. Step 1. What should I see? Well, you should see the approved mixture with a consistent consistency from delivery to delivery. Step 2. What am I actually seeing? Unusual wetness that totally deviates from all the morning batches. Step 3. Why does this difference matter? Because excess water significantly weakens the final compressive strength and the durability of the concrete. Not to mention, it's probably going to cause sagging on the wall. So, step 4. What action is required? You've got to step in, verify if the mixture is still within the approved limits, and formally document the deviation. Remember, just because it pumps easier absolutely does not mean it's acceptable shotcrete.
Okay, on to field scenario number 2. This time, you're observing a dry mix operation. Out of nowhere, the whole area just fills with heavy dust, and you're seeing unusually high amounts of rebound just bouncing right off the wall. The nozzle man is clearly struggling to keep the material sticking to the surface. So, what is the actual issue happening right in front of you? Let's break it down again. What should you see? A nice, moist, stable placement with a totally normal, controlled amount of rebound. What are you seeing? A total dust storm, excessive rebound, and a super unstable placement. This almost always means there's not enough water at the nozzle or there's some other serious delivery problem. Why does it matter? Because dry, sandy shotcrete like that creates terrible encapsulation around your reinforcing steel, leaving you with a weak, laminated, useless material. So the required action? Document this observable condition right away and make sure the crew corrects the operation immediately. You have to catch this before that poor dry material becomes permanently embedded and hidden inside the structural work. And here is our third and final scenario, and honestly, this one is really going to test your boundaries as an inspector. You're on a job that's using an accelerator. The crew decides, totally on their own, to just bump up the dosage. Why? Because they want the overhead material to set up faster, so they can speed up their workflow and go home early. Is this allowed? And how exactly are you supposed to handle it? Now, what's really interesting about this slide is how it perfectly defines your authority on site. What should you see? You should see controlled admixture use that matches the approved mix design. What are you seeing? A completely unauthorized field adjustment. Why does it matter? Well, messing with admixture dosages randomly like that completely risks the mixture's compatibility. You could easily compromise the entire hydration process and totally ruin the long-term strength. So what's the action? Any field adjustment absolutely must comply with the approved mixture and the official project procedures. You verify the approved mix, you document the deviation, and you follow the nonconformance process. But hear this loud and clear. The inspectors should never, ever independently choose or approve an admixture dosage yourself. That is strictly not your role.
Bringing us to Section 6, Key Takeaways.
Let's hit these 3 rapid-fire key takeaways straight from the source material. Number 1, the shotcrete mixture has to be fully compatible with the delivery process, the equipment you're using, and the actual conditions in the field. Number 2, remember the golden water rule. Dry mix water control happens right at the nozzle. Wet mix water is already in the mix before it's even pumped. And number 3, your primary job is to observe, document, and verify any changes in how the mixture behaves against the formally approved system. Don't play guessing games and try to diagnose beyond the evidence. Just report exactly what you see. Look, if you remember only one single thing when you walk onto a job site tomorrow, let it be this field takeaway. Do not judge a mixture solely by whether or not it comes out of the hose. Seriously, just because it pumps doesn't mean it's right. You have to judge it by whether it actually produces stable, dense, properly placed shotcrete once it's on the wall. And that wraps up our explainer on materials and mix properties. But it does leave us with a pretty provocative question. If the mix design is absolutely flawless, perfectly engineered, but the crew isn't communicating with each other, exactly how quickly can a good mix turn into a complete structural failure?
Well, we are going to answer exactly that in our next lesson, Clip 7, where we cover equipment, the delivery system, and crew communication. Stay focused out there, and I'll see you in the next explainer.